today we're going to take a look at describing number patterns, and we're also going to take a look at how we can use an input-output chart, or as we'll start to refer to it as a term value chart, to help us find the patterns and create expressions that we can use to find growing or increasing patterns. Now, before we get started, let's just take a look at a couple quick reminders. First of all, when we are dealing with number patterns, we do want to keep in mind that if this is a graph, we're always going to create straight lines. So if we were to take our chart, let's say we were to put the terms across the horizontal axis and the values up the vertical axis, and we were to actually graph on, and I know we don't have any numbers here in our value column, but let's say we were to graph on all those numbers, what we would actually get is a nice straight line. So what we're going to create, or what our charts are going to create, are what are called linear patterns. So again, straight lines are going to be created, and the great thing about this is if we were to create a line or graph something that we had up to a certain point, if we were to just take a ruler and keep on going out into wherever we want to go at and keep following that nice straight line, we would be able to predict what a term, let's say way out here, would be without having to actually do all of our charting. So we can also say that these are predictable. Now, let's use a quick little example that we may have seen before just on how we can describe our number patterns. So let's say for our term numbers, we've got 1 through 5, and this is just the numerical number of the term. And let's say our output or our values were 3, 6, 9, 12, and 15. Now, again, we can see that each of these is increasing by the same amount. So if we wanted to describe our pattern, we could say that our pattern starts at 3, and this is something that you've done before, and then we have to look at, so we want to give a starting point, and then we want to look at how our pattern changes. So from term 1 to term 2, term 2 to term 3, term 3 to term 4, etc., how does our pattern change? So in this particular case, because we have a nice even pattern and everything is increasing by the same amount, we can say that first of all, our pattern starts at 3, but every single time we add 3. So that would be how we could describe our pattern rule. Now, the part that we're going to add to your knowledge is how can we take this information, or how can we take what we found here, and how can we use it to create an expression? And what we're going to learn is how we can use the value, because that's actually what we want to focus on, to create our expressions. And that's what we'll practice in a few minutes coming up. All right, one of the skills we're going to get very comfortable with and very good at is using a specific expression to help us determine the output value of our input terms. So in this particular case, example number 1, what we're being asked is to substitute n, so n is just standing for number. So we're substituting n, 1, 2, 3, 4, and 5 to generate a number pattern. So what that means is when we have term number 1, we're using that term in our pattern. So in this particular case, n equals 1. For our second term, n is equal to 2. For our third term, n is equal to 3. For our fourth term, n is equal to 5. For our fifth term, for our fourth term, n is equal to 4. And for our fifth term, n is equal to 5. So what we're doing is using numerical amounts to replace, and that's going to help us figure out and determine the value of each term. So using some simple BEDMAS, I can think I've got to work through my BEDMAS, so I've got to do the multiplication part first. So 3 times 1 is going to give me 3, and then when I subtract 3 away from that, that's going to leave me with a value of 0. When I take a look at term number 2, 3 times 2 is going to give me 6. When I subtract 3 away from that, that's going to give me 3. So what I can keep on doing is filling in my patterns to help me figure out my value. So what this is telling me is that term number 1 is going to be a 0, term number 2 is going to be a 3, term number 3 is going to be a 6, term number 4 is going to be equal to 9, and term number 5 is going to equal to 12. Now the second part of what I am asked to do is to write a pattern rule. So simply what I can look at is what do my values start at, and how do they change from term to term. So in this particular case, my pattern rule, I can say that it starts at 0, and then I want to look at how it changes every single time, and I can say that we add 3. And what we can start to look at is the fact that this explanation or this description describes 3n minus 3. Now that's going to come in handy after, because when we start to have to generate our own expressions, we can start to look for, again, patterns and use our patterns to help us generate that. Take a second and try the examples on the next page on your own. So we've completed, or you've completed, the examples B, C, and D on page 2, and this is what you should have hopefully come up with. When using 5n minus 2, what I've done just only for the first term is shown, here's the 5, n is going to be equal to 1, so that's going to be my term number that I use. Then I'm going to subtract 2 after the fact, which is going to give me a value of 3. Now if you like, you can write out the expressions every single time if you feel that you need to do that. If you feel that you can just do those simple calculations in your mind, that is no problem. There will probably come sometimes later on where you're going to have to write some stuff out because they're going to be slightly more challenging. But for the time being, if you can just write them out, that's no problem. So what we should have as our values are 3, 8, 13, 18, and 23. And when we're describing our pattern and how it changes, we can see that we're starting at 3. That's the value of term number 1. And we're adding 5 every single time. So this explanation or this description gives us how our patterns are going to change, or how our values are going to change for the expression 5n minus 2. I want you to, as we go through the rest of these, just keep in mind kind of some similarities, or look for some patterns in our descriptions and our expressions. So just keep that in mind. We'll come back to that in a minute. For example C, what we have in our values column are 7, 10, 13, 16, 19. And again, we're starting at 7, so that's the value of term number 1, and we're adding 3 every single time. And again, we're so far working with patterns that change evenly or equally every single time. So we can say that that description, or that describes our expression of 3n plus 4. And lastly, for example D, what we have in our value column are 6, 13, 20, 27, and 34. And again, we can describe this as starting at 6, adding 7 each time. And again, that description gives us information, or tells us what happens when we have our pattern, or expression, sorry, of 7n minus 1. Now, I'm just going to scroll back up so you can see these two here. But the one thing that I want you to hopefully notice is our multipliers. So here we have a multiplier of 7, and we're multiplying that by our term number. And I want you to take a look for somewhere in this area, where else do you have that 7? Perfect. What you've identified is that whatever we are adding becomes basically what we're multiplying by. So that is something that we need to keep track of. If you want to see if that happens again, here we're adding 3, and that becomes our multiplier. So this is kind of a little hint, or a little tip, or a trick that you can use to help you determine what you're going to multiply by. And then, as we'll learn in about 30 or 40 seconds, we can figure out what we have to either add or subtract to that multiplier in order to get a value that works for us. So again, if that's a little fuzzy for you right now, don't worry, we'll practice that in just a minute. All right, here's where we're going to start to use some newly acquired skills, as well as some skills that we already have established, to help us really start to figure out patterns, expressions, and use our term and value charts. So in question 2, or example number 2, we're asked to do a whole bunch of things for each of our term and value charts. So first thing we want to do in part I, or part 1, is describe the pattern and write the pattern rule. So when we take a look at our value column, we can see that we start at 9. That's really the easiest part because we can always identify that. Then we have to look and see, okay, what and how are our values changing from term to term. So in this particular case, because they're changing by 2 every single time and that's being added, we can say that we can add 2. Now it's that add 2 that's going to come in handy in a couple minutes, but we'll come back to that in a couple minutes. For question 2, it says to use a table to find the 11th term. So what we'd have to keep doing, or what you would have to keep doing is, keep writing this down. So you'd write term 6, term 7, 8, 9, keep on going all the way down to term 11 to calculate and figure out what the value of term 11 would be. Once you've taken a couple minutes to do that, what you should have come up with is the fact that term 11 is equal to 29. Now, step 3, and this is really the kind of key part that in the future is going to help us solve questions like question 2 really, really straightforward. It asks us to write an expression for the nth term. So the nth term just means that we're going to create something that regardless of what term number we have, this expression is going to help us calculate and figure out the value of that term. So if we had the second term, we could figure it out that our expression is going to equal out to 11. If we wanted to figure out the 27th term, instead of having to draw a table or a chart that was 27 rows long, we can just use some math to help us, and that expression to help us calculate that. So here's where we have to go back to what we've described in our pattern rule. So this add 2, what we want to do right away is take that and make that 2n. So what we have to think about then is, what would we either have to add, or in some cases it might be subtract, to that number, or to that 2n. So what numerical amount will we have to add or possibly subtract to that in order to get it to equal our value. So if, let's say, we're looking at term number 1. So if we had 2, and then we replace the n with term number 1, or a 1, what do we have to add or subtract to that in order to get a value of 9? So because our number or our value is larger than what we're going to have here, because this is just going to equal to 2, we can think, oh, 2, I'd have to add to that 7 in order to get me to 9. Now, the one thing I will caution you about is we don't want to just let this work for only the very first term. We do want to try it with a couple. General rule is to try it with the first 3 terms, and if your values equal out, then that is good. So we know that for term 2, our value is 11. For term 3, our value is 13. So we're going to try, just to double check, 2, and this time we're going to replace that n with the number 2 because that's term 2, or our second term, and add 7, and then plus that. Oops, that should be a 3. So what we want to make sure is 2 times 2 is 4, plus 7 is 11, so that one works. 2 times 3 is 6, plus 7 is 13, so that one works. So what we can say is that an expression that will work for this particular set of patterns is going to be 2n plus 7, and that is what we're going to use moving forward. Now for question number 4, what we're asked to figure out is, what would we get, or what would be the value of the 50th term? So here's where we can do a little bit of replacing. We know that 2n plus 7 is our expression, so we can write that out. But what we want to do is we want to replace the n with the number 50, because that's going to represent, that does represent the term number. So 2 and 50 plus 7. So when we multiply and do a little bit of adding, we can figure out that the value of term number 50 is going to be 107. So that is how we can use our expressions to help us find out our values down the road. Let's take a look at question B together, and we'll do this one a little bit more quickly. So for the first term, okay, we're given our numbers up across the top, so we can just write those in. So we've got 9, 14, 19, 24, and 29. Part 1 asks us to discuss or describe what our pattern rule is. So in this particular case, we can say start at 9, and then each time we're going to add 5, and that's going to come in handy in a couple minutes. Part 2, if we were to figure out the 11th term, we could continue our chart along, and what we would figure out is that our 11th term would be equal to 59. For part 3, and this is where we're going to use that plus 5, so we're going to take that and we're going to make 5n, and then we have to figure, okay, if I do 5 times 1, what do we have to either add or subtract to that to get it to equal a value of 9? I'm going to think about that for a second, think about what works. I'm going to say, okay, that's going to be plus 4. I do want to double check, okay, if I did 5 times 2, it's going to give me 10, and add 4 more, is that going to give me 14? Good, that one works. 5 times 3, and I'm just doing this in my head, 15 plus 4 more is going to give me 19. Good, so that works. So I can say that that pattern rule is going to work for me, or that expression is going to work for me. Now, if I want to figure out the 50th term, again, 5n plus 4, I can replace the n with 50 because that is the 50th term I'm looking for. And when I do a little bit of multiplying and then a little bit of adding, that is going to give me a term value of 254. Now take a second and try example C on your own, as well as all of the questions on the following page. Answers for that will be posted in your answer files